Hi, Professor Caroline. What are we going to talk about today?
Hi, Ivan. Today we're going to talk about drones and slum mapping.
I think the first question is, why do we use drones?
Okay, so drones, taking a step back, are sometimes called unmanned aerial vehicles, or RPAS, they're kind of known under different names, but many of us have seen them in the shops already. You know, I'm buying a toy drone and then using the camera function also to either video ourselves or take videos of different events and pictures. But actually we can use drones also for Earth observation, so like a lot of the other things we are doing at ITC. So essentially what we can do is we can fly the drone over different areas and take pictures of the ground below to collect information, kind of like you have when you use satellite imagery.
And why don't we just use the satellites?
Well,
They're already there.
Today we're lucky, you know, it's actually a very sunny day in the Netherlands, but you can imagine that if it's a cloudy day, like unfortunately happens in other places or a lot in tropical areas as well, if you have a lot of clouds, then the satellite cannot go through the clouds to take pictures of the ground below, whereas a drone you don't have this. Also, drones you can get a lot more detailed information. So when we work in Earth observation, we talk about the spatial resolution, which is like the pixel size. Mm-hmm. And then with satellites, sometimes we will get about 50 centimeters, so sub-meter resolution, which is what's available on the market.
So that means that one pixel means a square on the ground of 50 by 50.
50 by 50, exactly. So you can imagine that maybe this table would be like 2 pixels or something in the UAV image, or in the satellite image. Mm-hmm. But because the drones fly lower, and with the different cameras, we can actually see a lot more detail in them. So then instead of 50 centimeters, we're looking at sometimes even only 4 centimeters or 7 centimeters, depending a bit how high we fly and which camera we're using. But so essentially because of that, we can see a lot more detailed information.
And why do we need that detail?
Well, because we can see a lot more with it, and it's really incredible. We can get so much more detail out of the drone imagery. We can see much smaller objects. Mm-hmm. So if you look at satellite imagery, maybe a couple of buildings would be more difficult to distinguish, whereas with drones we can see them in a lot more detail. There are projects also that we are doing here at the university, for example, looking at how you can use drones to look at the quality of streets, for example, okay. Because then you can see the cracks in the street and you can see a lot more information.
Oh, nice. And is there, well, we're talking at quite a lot of resolution already. Mm-hmm. Is there too much resolution? Do we get to a point where, okay, we don't need this anymore?
Yeah, that happens, especially when we get to the data processing part. So you can imagine that, I mean, drones, because you get a lot of detail, you don't always need all this detail if you are covering a very large area. So of course, if you want a lot of detail in a larger area, you're going to get a huge data set, which mm-hmm. means a lot of processing, everything is much slower. So also before you use drones, then you should think about what kind of data you really need, if you need the extra spatial detail or not. And another benefit of drones compared to satellite imagery is that the satellite follows a constant path, so you don't have a lot of control of when it takes the image. Whereas if you have a drone and you essentially have it with you in a suitcase, you have a lot more control about when you collect the data. So you see that drones are more often used for tasks where you need a lot more detail, so you're looking for smaller objects, or also if you need a lot of control on how often you collect the data. Okay. So if you think of like monitoring for mining, or for example a building construction, you could theoretically fly a drone every day if you want, and then you can see exactly how the changes are happening.
Okay. Now, one of the problems, especially
mm-hmm.
here in Europe and in North America, are the rules of where you can fly drones. Yeah. And how does that affect your work?
Exactly, that can be quite problematic, and also because at ITC we work with a lot of international companies, and you can imagine what it's like when you try bringing a drone from the Netherlands or Europe where you buy it to a country, for example, in Africa or somewhere else in the world where they have different regulations. So unfortunately we've often had problems that drones are stopped at borders, and to get them through with customs can be very difficult. We are working together, so when I started using drones, there weren't so many regulations in place yet, and they are still evolving a lot. But also at the university, we have some pilots who are dedicated and who also have all the certifications that are needed to fly.
And what is the common workflow for capturing images with the drone? So, for Earth observation?
Yeah, so the first thing you need to do is you need to have an idea of what information you want. And then once you know which information you want, you know when you will go to a study area, you will think of how big of a study area you want to cover to make sure that you can then plan the flight adequately. Because when you plan the flight, you need to think of the overlap between the images. And also, I alluded to it before, but by changing the flight height, you can also get more detail or less detail. So again, the same thing that you mentioned before, that you can get more detail, but you might need to fly lower, and so it will take longer. Or if you don't need it, you can fly a bit higher and cover the area faster. So the first thing you do is essentially go into an area and you do the flight planning. Then you fly the drone itself, so you go to the field, and sometimes it's one of the more exciting times, right? You get a lot of nice reactions sometimes from the people around. You collect the data, and essentially when the drone is flying, what we usually do is we look down and we take individual images. So the drone is taking different images. And then back on the computer with photogrammetry, we can combine all the images to get what we call an orthomosaic. So it looks more like a satellite image of just a seamless image from above. And we can get a point cloud, which is a 3D model. And you can also get the digital surface models, which essentially gives you the elevation of each point.
Oh, nice. And is this, usually when we talk about Earth observation, we're talking about a lot of different spectrums of light. Is this only visible spectrum? Because this is what's standard on a drone. When you buy at the store, it's just a visible light camera.
Exactly. So that depends on whatever camera you are putting on the drone. So like you said, a lot of the ones that we buy in the store are just a visible spectrum. So the same we can see with our normal camera, maybe on your smartphone. And that is good. For example, I used a visible camera because for my work it was an urban application, and this was enough. If you look at using drones for crop monitoring, for example, then you want to have at least the near infrared, because that's a very important part of the spectrum for vegetation. And sometimes you can even put hyperspectral cameras on drones, so you get a lot of different spectral bands, and you can get more detailed information of the spectrum. Or people even are putting LiDAR on drones, so then you can really get LiDAR point clouds.
Do you want to be a GeoHero as well? Then take the first step and click the subscribe button and then the bell button to always be the first to know when one of our GeoHeroes posts a new video.